We're in our second video for section 4.3 over exponential functions. In this video, I'm going to define the number e for everyone, and then we're also going to look at solving some different exponential equations, okay? Now, the number e is a really special number. It shows up in a lot of applications, and you're going to see it repeatedly throughout the rest of this chapter, okay? So the number e is defined to be the value that the expression 1 plus 1 over n to the power of n approaches as n gets infinitely large. Okay? So based on that definition, we're going to approximate the value for e by plugging in larger and larger values for n. Okay? So starting with n equals 1, this one's easy enough to do by hand. 1 over 1 is 1, 1 plus 1 is 2, and then 2 to the first power would be 2. So that tells me the value of e is somewhere around 2. Okay. Now I'll use the calculator to plug in 10n for n. Right? So 1 plus 1 over 10 to the power of 10 is roughly 2.59. What about 100n for n? 1 plus 1 over 100 to the power of 100, 2.7. Okay, we'll keep doing this. Let's make n 1,000 now. Right, 2.7169. So notice the last two results, I'm out to the tenths place as a value of 2.7. Okay, and let's do 1 million now. Right, and we're going to stop there, and we'll say out to 3 decimal places we can see that e is approximately 2.718. All right, now the nice thing about most calculators is that they actually have the value of e programmed into them, the exact value of e. So ours on the graphing calculator is located right here. If I hit second and then my division symbol, it'll insert that e, and then I can hit enter, and notice here is the true value of e. Okay. Now we're of course in the section on exponential functions, right? So if I make e the base of an exponential function, to where f of x is equal e to the power of x, this is considered the exponential function. Okay, it's kind of like for any alumni of the Ohio State University, notice we say the Ohio State University, not just Ohio State University. Okay, so this is kind of the same idea. If you're working with the exponential function, it's known to be the function whose base is e. Right? E is just a regular number, real number, just like any other real number out there. Okay. All right. Now let's get into some examples of some exponential equations. One of which involves the value of e. Okay. When you're given an exponential equation to solve, you want to first try to solve it by rewriting both sides of the equation in terms of the same base. So in my first example on the left-hand side here, I have 16 raised to the power of x plus 2 equaling 64. I can write 16 and 64 both in terms of the same base, that being 4. Right? 16 is 4 squared. And then 64 is 4 cubed. Okay. Now I use a little property of exponents on the left-hand side here, and I'm going to multiply 2 with x plus 2. So now I have 4 is raised to the power of 2x plus 4, and that's equal 4 to the power of 3. Well, if I have two expressions equivalent to each other that have the same base, that means their exponents are equivalent. So I can ignore the 4's, and I can just set 2x plus 4 equal to 3, solve for x. means x equals -1/2. And of course you can check that if you were to plug -1/2 back in for x in the equation, it should simplify out to equaling 64. Okay. Right, now in the second example, my equation involves this newly defined value of e. And for this example, I don't really need to know what e represents. Okay, we can leave e in an exact form here. Really, what we need to do is get the right side of the equation simplified down to where you're only seeing e one time. Okay, so I'm going to leave the left as e to the power of -x squared. And then I'm going to use some properties of exponents over here. E to the power of x raised to the second power, that's equivalent to e to the power of 2x. And then 1 over e cubed, isn't that the same as e to the power of -3? Right, and then I can add those two exponents together to rewrite this as e to the power of 2x minus 3. Now I have a single expression of e on both sides of the equation, and that means that their exponents are equal to one another. Right? So now I'm going to set this equal to 0, factor, x could equal -3, or x could equal +1. All right? So there's two examples in which you can solve an exponential equation by getting both sides of the equation down to the same base.